A plug fan and a housed centrifugal fan can use the same backward curved wheel and still behave like two different machines after installation. The reason is not the blade. It is what surrounds the blade. One fan gives the air a scroll and a defined outlet. The other gives it an equipment plenum. In the next 4 minutes, we will isolate that one difference, show where each design wins, and build a selection checklist you can actually defend. Start at the impeller. Air enters axially through the inlet cone, gains energy in the rotating wheel, and leaves the blade tips mainly in the radial direction. At that instant, the two arrangements can be very similar. Now add the boundary around the wheel. In a housed fan, a volute or scroll wraps around the impeller. Its flow area generally increases toward the discharge. The scroll collects the radial flow, manages part of the velocity field, and guides the air toward one rectangular outlet. That defined outlet is useful when the next component is a duct, elbow, silencer, or a fixed connection. Rotation and discharge orientation are therefore part of the product selection. A plug fan removes the dedicated scroll. The impeller discharges around its circumference into the air handling unit plenum. The plenum is not empty space, it becomes part of the aerodynamic system. Its walls, coil face, filters, structural members, access doors, and final outlet all influence how the velocity field decays and how static pressure is recovered. That difference changes the integration problem. With a housed fan, the manufacturer controls much of the immediate discharge geometry, but the designer must still provide a sensible outlet transition and avoid an abrupt turn close to the fan. A scroll does not guarantee uniform discharge. The velocity profile at its outlet can be asymmetric, and poor downstream geometry creates system effect loss. With a plug fan, the equipment designer controls more of the discharge environment. Good inlet clearance, concentric inlet cone alignment, separation from nearby walls, and an unobstructed path toward the downstream coil or outlet are essential. Put the wheel too close to a wall, or let high-velocity air short-circuit back toward the inlet, and the installed duty can move away from the catalog prediction. Pressure definitions also matter. Fan total pressure equals static pressure plus velocity pressure at the defined fan outlet. For a housed fan, that outlet has a clear rectangular area. For a plug or plenum fan, test standards define the outlet differently because there is no conventional duct opening. So never compare two catalog efficiencies until airflow, density, pressure definition, test category, drive input, and system boundary all match. Now consider packaging. A plug fan can simplify an AHU layout because the discharge is not locked to one scroll orientation. Direct drive units can be mounted through a partition, and several modules can share a plenum. That supports scalable airflow, part load staging, and redundancy, but those are system design benefits, not automatic properties of every installation. A housed fan is often the cleaner choice when the discharge must connect immediately to a defined duct, when outlet direction is fixed, or when the project team wants the flow collection geometry delivered as part of the fan. The casing may require more envelope, and changing the outlet orientation can be less flexible, but the connection boundary is explicit. Maintenance can break the tie. Draw the real service path before selecting. Can the plug fan motor and wheel be pulled through the access side without removing a coil? Can a housed fan belt, bearing, motor, cutoff, and casing interior be reached safely? Direct drive versus belt drive is a separate decision. Do not assume one motor architecture from the presence or absence of a scroll. Here is the practical selection sequence. First, lock airflow, static or total pressure, air density, temperature, sound limit, and operating range. Second, draw the actual installation boundary, inlet, clearances, plenum, coil, outlet, and every early turn. Third, compare tested configurations at the same duty and pressure definition. Fourth, check input power and sound across normal, dirty filter, and part load conditions. Fifth, validate access, redundancy strategy, controls, and lifecycle cost. So which one wins? Choose the plug fan architecture when a properly designed plenum, flexible layout, direct drive integration, or modular arrays create system-level value. Choose the housed architecture when a defined directional outlet and conventional duct connection reduce integration risk. Neither label guarantees lower power, lower sound, or better performance. The best option is the complete tested fan plus the real installation around it. If you want one project reviewed, send the duty point and a simple section drawing. Longwell can compare both boundaries with every assumption visible.